Welcome investors to Potato Construction's visualization of the design brief. Here we will be showing you the completed computer modelling for the portal frame, the structural loads which led to the key design conditions, and the frame spacing decisions and their rationale which led to the final design. This, ladies and gentlemen, is the architectural representation of the portal frame. It is 20 metres wide, 40 metres long, 10 metres high at the eaves with a 6-degree roof pitch leading to an eave height of 11 metres. The columns and the rafters are both hot rolled structural steels, with the apex and eaves joined by bolted plates and the columns cemented and bolted into the concrete slab. Firstly, our initial rafter and column sections were made using the suggested data from the One Steel structural steel catalogue. These resulted in the original architectural model in Revit. The second step was to reproduce this model in space gas for structural modelling, which resulted in the first problem to be solved. Although the specifications were advised by One Steel, they resulted in failure in accordance with AS 4100 for most of the rafters and columns. This is the critical load path, displaying 120% of dead load combined with 150% of live load, resulting in the failure of the structure. To solve this, larger columns and rafters were systematically applied and tested in space gas until the final viable design was produced. Bracing was only necessary at the end segments to stabilize the structure and improve performance for lateral loading. Here is a brief visualization of the various load combinations which had to be structurally considered in accordance with AS 4100 and AS 1170. Live load and wind load specifications were generated for the New South Wales region in Portal Frame Builder, with the dead load of 14 kilonewtons per metre imposed on the rafters as roof dead load plus self-weight. These loads then needed to be combined to test AS 4100 design standards such as 1.2 dead load plus 1.5 live load, 0.9 dead load plus ultimate wind load, and 1.35 dead load and the serviceable wind load. The frame spacing decisions were made using data from portal frame introductions received as part of the 201 course. The suggested spacing was between 5 and 8 metres, leading to design choices of 5 metres for the end spacing and 6 metres for the interior spacings. This results in good design performance and minimises materials costs. Bolted plates were chosen for the apex and eave connections due to their strength properties and ease of installment on site. In closing, we hope you all have enjoyed seeing the vision for the portal frame and are all filled with as much anticipation and confidence for this project as Potato Constructions.